So under this evolution of behavior among hominids, hominins, Homo sapiens, and so on, let's add a few more interesting things that are a little bit away from climate and evolution, but they are very closely related, because this again raises a question of just looking at past evidences of things and climate variability, interpreting specific evolutionary features may be problematic. And this one is a good example that argues that developmental dyslexia is not a disease or a handicap or something to worry about, but actually it may have evolved as something that it blesses people with some advantages. So starting with the abstract, I'm just taking a few sentences. However, people with developmental dyslexia are also often proposed to have certain strengths. This is also true for some autism people, for example. They may have trouble making social connections, but they can be mathematically very good, musically, and so on. And there's a movie called Shine that you can look at based on a true story and so on. Particularly in realms like discovery, invention, and creativity, that deficit-centered theories cannot explain. So if you think this developmental dyslexia is a deficit of some sort, then you may miss these ideas. We investigate whether these strengths reflect an underlying explorative specialization. We re-examine experimental studies in psychology and neuroscience using the framework of cognitive search, whereby many psychological processes involve a trade-off between exploration and exploitation. So if you have a group that is exploiting and then you have somebody who's good at exploration, you can see how that combination can lead to a good cooperative societal behavior, beneficial as a whole. We report evidence of an explorative bias in DD-associated cognitive strategies. High DD prevalence and an attendant explorative bias across multiple areas of cognition suggest the existence of explorative specialization. An evolutionary perspective explains the combination of findings and challenges the view that individuals with DD have a disorder. In cooperating groups, individual specialization is favored when features that confer fitness benefits are functionally incompatible. So fitness benefits are functionally incompatible, but individual specialization is favored in that sense. Evidence for such specialization suggests that, as with some other social organisms, humans mediate the exploration-exploitation trade-off by specializing in complementary strategies. The existence of a system of collective cognitive search that emerges through collaboration would help to explain our species' exceptional adaptiveness. So in this sense, it is environmental adaptation and not genetic adaptability. Adaptability and not, this is genetic adaptiveness. It's also aligns with the evidence for substantial variability during our evolutionary history, and the notion that humans are adapted not to a particular habitat, but to the habitat variability itself. So you're not necessarily adapted just to the cold, but the fact that you have seasonally and intriannually and decadally varying cold and warm temperatures. Okay, so let's look at how this paper wants to look at exploration. Terminology used to describe exploration and exploitation across fields with different papers that from which this is taken. Search, variation, flexibility, experimentation, discovery, and innovation. Global versus local. So exploitation would look at refinement, choice, production, efficiency, selection, and implementation, but in a local sense. This is an extensive and divergent trait, whereas here it is intensive and convergent. So you are exploring, obviously it's very extensive and divergent, whereas when you're trying to exploit, let's say, a resource, you are becoming intensive and convergent to where that resource may be maximum, or seek only places where there is the same resource available. Diffuse, this can be very focused because you want to hunt and gather, then that is exploitation. You have to be very focused, whereas exploring means what else is out there. Diffuse. Breadth and gist, depth and verbatim. So let's not get into too much of that psychological lingo, but just to kind of add to this story a little bit, we have looked at, and we will continue to look at, climate variability going more than 5 million years ago here, so 3 millions to today. We have talked about the transitions from precision obliquity timescales slowly over the Pleistocene to the ellipticity or 100,000 year ice age cycles, and that corresponds not only to different amplitudes and durations of climate change, but also the variability of the duration and amplitude itself over the evolutionary time scales, which is critical. So climate fluctuation indicated by oxygen measurements, which we have seen and we will see again in many places. But if you look at that with brain case volume, which also we have looked at and will continue to look at in different contexts. So this is measured in cubic centimeters, smaller brains to larger brains, and we know that sapiens, Neanderthalensis and sapiens had large brains, but Neanderthals had lesser cognitive abilities from what we can infer so far. So here we are growing in size, as we have talked about, and then there is this non-linear variability of the brain size in a very short time. So you have large increases that are happening in a very short time over this nonlinear, or this very coarsely resolved timescale axis here. But is that related to variability? The lower graph showing the increase in cranial capacities of hominin fossils over the last 2 million years, indicating an increase in brain size primarily within the genus Homo. Cranial capacity data is taken from some source. The upper graph shows Earth's climate fluctuations during the same period, including the strongest fluctuations which coincided with the greatest brain size increase. So this is amplitude and time together is the largest variability, whereas time scales were faster here, but amplitudes were smaller in terms of temperature variability, let's say, which comes with dust and rain and glaciers and other signals as well. Okay, so basically I wanted to include this here because dyslexia may have evolved as a beneficial feature which added to community which was exploiting, because if you have a couple of people who are very good and specialized in exploration, obviously that brings added value to a group of hunters gatherers who are exploitative. This is an interesting idea. Obviously there will be newer papers coming out on this, I'm sure, but as I said, the spectrum of autism and other specific syndromes like Asperger's syndrome and so on also have always been looked at, whether they have a certain features like a disability to connect socially or communicate well, but being very systematic mathematically, or being good at learning music and multiple languages and so on and so forth. So this here tries to connect brain size and climate, which you have done again and again, but it doesn't explain how developmental dyslexia would get selected. Maybe it's a mutation that ends up being advantageous and survives, but is that a genetic adaptation, or is that a random mutation? Because it isn't clear that dyslexia is inherited right now, but why do some kids end up even when the parents don't have it? Or is it that the parents are carrying some genetic signature, and under certain circumstances, when two parents with embedded genetic signature for developmental dyslexia end up imparting it to the child, or is it environmental, and so on and so forth. So those are different discussions, but just focusing on climate change again, increased cognitive abilities and brain sizes do come with these features, which often are considered deficits or disorders, but maybe they have special benefits. Okay.